everything you have here, okay, anything in the yellow box with sum and distance formulas. We're going to have sum and distance formulas, cosine and sine go together, and then we'll talk about tangent at the end. So whenever you have sum and distance formulas of sine and cosine, okay, again, similar to like whenever we talked about product to sum and sum to product, okay, it's a lot of the same type of technique as far as what we're going to do, okay, and being able to write a sum of two angles as a product that's also getting added together. So whenever we have this, whenever you have cosine of either of the two angles, the cosine of each angle, your alpha and your beta, whatever, or your x and your y angle, whatever you want to call it, okay, are going to go together. Your two sine values are going to go together, and then, but your sine is opposite. So if it's a plus, it's going to be a minus in your actual product and addition or subtraction. Okay, so these two signs are opposite here with a cosine value, but with sine, everything is what it is, and it's going to be the same. So if it's a positive or a plus, it's going to be a plus within your formula. The only difference is whenever you have cosine of your two angles, cosines and sines are grouped together, whereas with sine, they are opposites of each other. So sine is with cosine, cosine is then with sine. Okay? You will always put your alpha angle or your first angle in the front. You'll always put your second angle or your beta angle second whenever we multiply. You're multiplying, it really doesn't matter, to be perfectly honest with you, but it just kind of helps keep everything in order. Okay? Just to be perfectly honest with you and to make it a lot easier. Now with this, I'm going to go to 2 first, and then I'm going to come back to 1. Okay? With most of these that we're going to give you, or really any of these that I'm going to give you, it's going to be angles that are going to be easy to work with. Okay? Whenever I say it's going to be easy to work with, that means it's going to be like 0, 30, 60, 90, 45, that sort of thing. Okay? So it's your values that you know, it's the values that you can cheat with your left hand and go there and find all of your values. So if I'm going to do 2, again, it says exact value. Okay? That doesn't mean it's a decimal. That means for the most part, it's either probably going to be a fraction or it's going to be some sort of radical. Okay? 2 in this hand, or in this case, is going to be one that you could actually put in the calculator and you could get the exact answer and figure it out. Okay? But that's not a case that's very often. So it's cosine of 80 degrees times cosine of 20 degrees plus sine of 80 degrees times sine of 20 degrees. So which of my 4, bless you, which of my 4 formulas, which one am I going to use? The first, second, third, or fourth one? Okay, it's like I've got to kind of go backwards, right? But which one am I going to use? The second one, okay? Because I have cosine and cosine, sine and sine, and it's addition, so it's going to fit right here. So then all I'm going to do is I'm going to take cosine of 80 degrees minus 20 degrees. Well, what is 80 minus 20? 60. So cosine of 60 degrees. You may or may not remember. Where is cosine of 60 degrees on my left hand? Is it the thumb, the pointer finger, the bad finger, the ring finger, or the pinky finger? Where's it at? 60? 0, 30, 45, 60. So here. Now, it is cosine, so is cosine the top side of my hand or the bottom side of my hand? Top side of your hand. So, top side of your hand, so square root, square root of 1, square root of 1 over 2, or 1/2. Whenever it asks for exact values, 1/2 is an exact value. Okay. On ones like number 1, though, where it says find the exact value of cosine of 15 degrees. I understand that you think, or there are some people out there, or in here, or listening to this video, that will think that if I just have this thing in degree mode, or maybe they'll try to put it in radian mode, and they'll just type in cosine of 15 and hit enter. And they get 0.965925826 and they write all of that down, and they're like, yep, that's exact. No. That's lazy. That will get you absolutely nothing. The exact value means that it is, again, going to be either a fraction or some sort of radical. It may be a radical in a fraction. Most likely will be. So again, if I have cosine of 15 degrees and you're like, Laws, I have no idea what 15 degrees is. Well, you're going to have to either add or subtract two values that will give you 15. I'm not saying do 16 minus 1. I'm saying use values that you know and that are easy for you to use, like 0, 30, 45, 60, or 90. Use values that are easy, not values that are going to make your life a living bad word. Okay? Use numbers. Which of these 5, especially, there's really 2 sets. Which 2 numbers would probably be the easiest that I can use to either add or subtract to get 15 degrees? 45 and 30. Okay? Is there another set that you could use? Yeah, I could use 60 and 45. That's okay. It's all going to work out. That's the good thing about this. Sometimes you have multiple options. If you went 60 and 45, go for it. Okay? But I can use 45 and 30, and I can subtract those 2 values. And I can take cosine of 45 degrees minus 30 degrees. Well, what do they represent? Well, the 45 is like my alpha, and then the 30 is like my beta. And I'm just going to use the formula that's actually number 2 again. So then whenever I do this, I'm going to have cosine of 45 degrees times cosine of 30 degrees plus sine of 45 degrees times sine of 30 degrees. Now, I may have people be like, why do we use those? Well, we know those, or we should by now know what cosine of 45 or cosine of 30 degrees are because of our little trick that we still have down here. What is cosine of 45 degrees? Square root of 2 over 2. So all I'm doing is just changing it to where it's an actual value. Square root of 2 over 2 times cosine of 30, 0, 30. Cosine, remember, is on top, so square root of 3 over 2. The second half then, with sine of 45, so 0, 30, 45, is again square root of 2 over 2 times sine of 30 here. Okay, sine is the bottom side, so 1/2. Focus on each one individually. What is the square root of 2 over 2 times the square root of 3 over 2? square root of 6 over 2 plus square root of 2 over 2 times 1 over 2. Square root of 2 over 2. Amazingly enough, they have, oh, not 2, my fault. What's 2 times 2? It's 4. Got in too big of a hurry. My bad. We were multiplying, not adding. The great thing about these are, though, is that they will always or should always have the same denominator. Because I'm dealing with the same values, normally 2, on the bottom side. It's not always going to be the case, but 99% of the time that's going to happen. So then whenever I write this, I'm okay with you writing as the square root of 6 over 4 plus the square root of 2 over 4. I'm okay with you having this here. You could also write it as square root of 6 plus the square root of 2 all over 4. Both of these values work. The one thing I don't want to see is I don't want to see the square root of 8 over 4. I can't add the square root of 6 and the square root of 2. Okay? And not make it the square root of 8. It's not the same thing. Okay? Because they're not the same value underneath the radical. If I had another square root of 2 up there, fine, that's great. But square root of 6 and the square root of 2 cannot be made into the square root of 8. Okay, so make sure that you don't make that silly mistake. So we're still verifying. We're just going to have to rewrite things. We have more formulas that we can use, or we have more ways of changing a cosine or a sine or later a tangent function to where we can verify what we have to be true. So if I have cosine of alpha minus beta, how am I going to change that top side? Don't get into the, we talked about earlier in the very beginning part of the chapter is try to write everything in terms of sine and cosine. Okay? Let's slow our roll a little bit on that and then just focus on one side at a time. Okay? It was all well and good whenever we were trying to figure this out and try to pick it up and learn it whenever it was all new. Now we want to really kind of pump the brakes on that and not do it every single time. Okay? So we don't necessarily have to. We could change cotangent of alpha plus tangent of beta and write it as cosine over sine and sine over cosine. We could, that's fine. Let's not. Just to make sure that we're not going to overcomplicate anything. This one's going to work out fine either way, but then we don't overcomplicate anything. So then, how am I going to rewrite cosine of alpha minus beta?
Cosine A, cosine B plus sine A, cosine B.
Right? So, cosine of alpha times cosine of beta plus, I did not give myself enough room, sine of alpha times sine of beta. Bottom side is what it is, and it's going to be sine of alpha times cosine of beta. I'm not going to worry about the right side for right now. I have one big long fraction. I have cosine of alpha and cosine of beta multiplied together. I have sine of alpha and sine of beta multiplied together. Then I have sine of alpha and cosine of beta multiplied together. I have one big fraction. One of the ways that we can go about this is to split this thing up. And if I split it up, I go, yep. So then if I have cosine of alpha times cosine of beta all over sine of alpha times cosine of beta. What's going to happen? Everything's getting multiplied or divided, so what's going to happen on that first one in red? Yeah, the cosines are going to cancel, right? Same way, it's still a plus. I'm still going to have sine of alpha times cosine of beta. But the top side is sine of alpha times sine of beta. What's going to happen in that one? The sine of alphas are going to cancel, right? So then all I'm really left with, and this is why I said that we could have changed cotangent and tangent if we wanted to, and it would have been just fine. It would have worked out to be nice and neat. Because if I have cosine of alpha over sine of alpha plus sine of beta over cosine of beta, what is sine over, or what is cosine over sine? Cotangent. So I have cotangent of alpha. What's sine over cosine? Tangent. Have I seen that before? You bet. The very beginning. It would just fall all the way down here to where they are equal, and cotangent of alpha plus tangent of beta. Verified. So on 5 it says, suppose that sine of alpha is 12 over 13 is in quadrant 2. Okay, so it's not in quadrant 1, it's not in the quadrant where it's all positive. It's in quadrant 2 where I'm going to have a negative somewhere, okay, with one of my values. Obviously it's not with sine because it's not negative here, it's positive. So hopefully that kind of gives you a hint that cosine is going to be negative. Then it says that sine of beta is 3 over 5. It is in quadrant 1, so that means everything's going to be positive. What I've got to do is I've got to figure out what are my missing angles, or what are my missing parts, rather. So for my alpha angle, I have x, I have y, and I have r. If sine is 12 over 13, where does the 12 go? Where does the 13? And then which one do I need to solve for? Which one's the easy one to put in? Hopefully. Sine is opposite over hypotenuse, or what over r? Is it x or y? Y over r. So if this is y and that's r, there's 12, there's 13. Now, I still have to find my x value. What do we know about my x value because it is in quadrant 2? It's negative. Okay? If there was only a way that I could figure out what x is, there was only a theorem, Pythagorean theorem, okay? Or an adjusted version of it. I'm going to go 13 squared minus 12 squared equals x squared. So 169 minus 144, 25 equals x squared. X is 5, but we already talked about that it actually needs to be a negative 5. I'm going to do the same thing with my beta angle as far as x, y, and r. Now in this case, because it is in quadrant 1, what do I know about my x, my y, and my r? They're always going to be what? They're always going to be positive. Okay, we already talked about with sine. Remember that it is y over r. So here's my 3, there's my 5. Do the same thing again. And take 5 squared minus 3 squared equals x squared. 25 minus 9, 16. X is equal to 4. So I kind of got the particulars out of the way. Once I do that, then it just becomes, if I'm going to use my addition or subtraction or difference formula with either sine or cosine, I have to know what all of those angles are. I have to know what sine of alpha is, what sine of beta is, what cosine of alpha and what cosine of beta is. That's all I need to know. I don't really care about tangent right now. I don't care about cotangent, cosecant. I may later if I have to flip things. That's okay. But as far as like part A, says cosine of alpha. Well, what's cosine? If sine was y over r, what's cosine? X over r. So, what's my x value? -5. My r value is 13. I'm going to come back to that in just a second. I'm going to do the same thing on part B, but I'm going to use cosine of beta. Again, it's cosine, so it's x over r. My x value is 4. My r is 5. Again, I'll use that in a second. Once I get everything, once I get the 4 angles that I need, once I get sine of both angles and cosine of both angles, then it just becomes, what am I going to do? Am I going to add the 2 angles together? Am I going to subtract them? Am I going to use sine? Am I going to use cosine? What am I going to do? So on C, if I have cosine of alpha plus beta. Well, what's the first part going to look like? Cosine of alpha times cosine of beta plus or minus sine of alpha times sine of beta. From here, it just basically taking my trig function and giving it a numerical value. What is cosine of alpha? -5 over 13. Where'd you see that at? Right there on part A, right? We saw that right here. So, -5 over 13 times, what's cosine of beta? 4/5. We'll come back to that in a second. Minus, what's sine of alpha? How do you know it's 12 over 13? Yeah, they told us that. 12 over 13 times 3 over 5. So then it becomes multiply, subtract. So whenever I multiply, I get -20 over 65. Don't worry about, no need to reduce it, because everything here, what should happen, should have a common denominator. So then, -20 minus 36, -56 over 65. Then check it for reducing, and boom, you're good to go. Okay? Again, no need to ever want to reduce here because you should get the same denominator. Why are you going to get the same denominator? Because your radius or your hypotenuse, whatever you're gonna call it, or your denominator, should always be opposites of each other. If they're not, then you probably made a mistake somewhere. Okay? You would do the same thing with sine, but then with sine, like on part D, you would flip them. So if we don't do it, if we would just set it up, like how this one should set up, you would use the same values. But like on D, where it is sine of alpha plus beta, it's going to go sine, cosine, cosine, but you're going to flip your angles. Okay? So like it would go, or cosine, sine, excuse me. So it would go like sine of alpha times cosine of beta, and then it's a plus, so I would add cosine of alpha times sine of beta. I would use the same numbers. I would still use 12 over 13 times negative 5 over, 4 over 5. And then vice versa, and go with negative 5 over 13 times 3 over 5. Okay? That wouldn't change. Still multiply, and still either add or subtract, and go from there. Here is just sum and difference formulas of tangent. Everything fits the same way as it did before. Okay? In terms of what you're going to, as far as your two angles, and how you plug everything in. It's not going to change. Okay? The one thing I would tell you, don't change it to sine and cosine, or sine over cosine. Okay? Keep everything as tangent, and kind of go from there. Okay? Your assignment is on Canvas.